Lesson 8.4, using scientific notation. Scientific notation should be just a review for you group of kiddos because, I don't know, I'm pretty sure y'all learned this back in your elementary years or maybe even last year. What exactly is scientific notation? Scientific notation is something we like to use for big numbers. And you're going to use this a lot in IPC and chemistry. Scientific notation is in the form C times 10 to the nth power. Okay, it's going to have a base of 10. C has to be greater than or equal to 1, and it has to be less than 10. So that could include 1, 2, 3, all the way up to 9. And it can also include any decimals that fall between these numbers. So, moving on. So scientific notation. That is a number written in a number is written in scientific notation when it is of the form C times 10 to the nth power, where C is greater than or equal to 1 and less than 10. And n is an integer. So let's look. An example would be if I give you 30 times 10 to the third power. Is this written in scientific notation? No, it's not, because 30 is way bigger than 10. Therefore, we would have to change that. But let's look at, say, 5.35 times 10 to the fourth power. Is this written in scientific notation? Yes, because 5.35 does fall between 1 and 9. Alright, let's say we have 16 million. In standard form, you know that it's going to look like this. In scientific notation form, 16 is bigger than 10. So if I change that to 1.6, the way I do this is I put the decimal right here, the 1.6. The decimal was originally right here at the end of this number. So to move from where I put it to where it originally began, I have to go 1, 2, 3, 4, 5, 6, 7. So I don't have times 10 to the 7th. Okay, 2 hundredths in standard form is 0.02, 2 hundredths. In scientific notation form, I'm going to have 2 times 10. Okay, you can see that I moved the decimal behind the 2. I moved it here. It originally started in front. So to get from where I put it to where it began, I have to move 2 spaces back to the left, so it's going to be -2. Alright, let's practice this some more. In example 1 on A, I have 7,820,000. Scientific notation form, I'm going to have 7.82 times 10 to the what power? Okay, well the decimal was right here originally. I placed it between the 7 and the 8. So I have to move 1, 2, 3, 4, 5, 6 to get where it originally began. So I'm going to have times 10 to the 6th power. And then on B, I'm going to say 4.01 times 10. Okay, I moved the decimal between the 4 and the 0. But I have to move back 1, 2, 3 to get to where it originally began. So that's -3. If you move your decimal to the right, you're going to get a positive exponent. If you move your decimal to the left, you're going to get a negative exponent. Okay, example 2, we already have it in scientific notation form. We want to put it in standard form. So what I do is I copy down the number without a decimal. This 9, it's positive, so I know I have to move my decimal to the right. I have to move it 9 times. Well, here I'm moving it twice. 1, 2. So 7 more times. That 7, we're going to use zeros as placeholders. So I need 7 zeros. 1, 2, 3, 4, 5, 6, 7. And then put your commas in where you need to. This is why we use scientific notation, especially when we're dealing with really large numbers such as this one. Okay, B, I have 9.097 times 10 to the negative fifth. I'm going to copy, oh, not yet, I'm not. Okay, I have to move my decimal negative 5, so I have to move it back to the left. So here I'm going to go 1. I have to move it 4 more times. Remember, those are my placeholders, so I'm going to have 1, 2, 3, 4, 9097. Alrighty, moving right along. Checkpoint number 1. Write the number 0.0899 in scientific notation. Okay, so I'm going to have 8.99 times 10 to the, I move the decimal here. It began over here, so to get back where it began, I have to move back to the left. So I'm going to have times 10 to the negative 2. And then it wants us to write 6.0001 times 10 to the 7th in standard form. So remember, I copy down the number without any decimals. I'm moving the decimal positive 7, so I have to move it to the right 7. So 1, 2, 3, 4, 5, 6, 7. Alright, example 3. Ordering numbers in scientific notation. I want to order the numbers 3.2 times 10 to the negative 4, 0.0004, and 2.8 times 10 to the negative fifth. Okay, I'm going to ignore all the book steps and I'm going to provide you with my own steps. This is to order numbers. Step 1 is if you start off with any number in scientific notation, you need to make sure all numbers are in scientific notation. Okay, so I'm looking at the numbers 3.2 times 10 to the negative 4, 0.0004, and 2.8 times 10 to the negative fifth. Okay, I can see these two in numbers are already in scientific notation, therefore I need to change the middle one to scientific notation. So that's going to become 4 times 10 to the negative 4. Okay? Your step 2, once you've got all your numbers in scientific notation, step 2 is you're going to order the exponents. The directions say from least to greatest, so I'm going to look at my exponents. In my exponents, I have negative 4, and negative 5. Well, I'm looking for the least number, and we're dealing with negative numbers. We know that negative 5 is farther away from 0, so this is your least number. So when I'm ordering my numbers, I know my least number is going to be 2.8 times 10 to the negative 5. Okay? Once I order it, I mark it out. My next two numbers both have negative 4s, so then I have to look at the number in front of the base. I have 3.2 and 4. 3.2 is less than 4, so next in order I'm going to have 3.2 times 10 to the negative 4. That's going to leave me with, put your number back in original form, so 0.0004. Alright, last example. Evaluate the expression, write your answer in scientific notation. Okay, I have 5.6 times 10 to the negative 4, and then 1.4 times 10 to the negative 5. So I'm taking this scientific notation number, multiplying it by this scientific notation number. So our step there is we're going to use the commutative property and associative property to multiply these. So my first step is I'm going to take this 5.6 times 1.4. Okay, that's how they got this step. And then I have to multiply my base and my power. So 10 to the negative 4 times 10 to the negative 5. That's how they got this step. 5.6 times 1.4 is going to give me 7.84 times multiplying like bases. Remember, what do we do with the exponents? We add them. So times 10 to the negative 9. This is in scientific notation, so that's our final answer. Okay, B. I can see that I have a power of a product, so this power I have to distribute to each factor. So that's going to leave me with 3.2 cubed times power to a power. What do I do with those exponents? I know I multiply, so I'm going to have times 10 to the 6th. Break this down. 3.2 cubed gives me 32.768 times 10 to the 6th. Okay, it says make sure our answer is in scientific notation. I can see that this number right here is not scientific notation. So I need to change just this right here to scientific notation. So what I'm going to do is I'm going to drop down this times 10 to the 6th. That way I don't forget I still have it. So now let's change this number to scientific notation. That's going to become 3.2768. Let's ignore this part because I've already dropped it down. Okay, so I move the decimal here. I've got to go to the one place to the right. So I'm going to have times 10 to the first. Okay. So that's going to become 3.2768 times 10 to the first times 10 to the 6th. Okay, remember, multiplying like bases, you do what with their exponents? You add. So we're going to get 3.2768 times 10 to the 7th power. This is now in scientific notation. And then on C, I can see I'm dividing, so I check the numerator. Is it in scientific notation? Yes. Is the denominator? Yes. So since I'm dividing, I'm just going to break that apart, and I'm going to have 3.5 divided by 1.75 times 10 to the negative cube divided by 10 to the negative 5th. Okay, what is 3.5 divided by 1.75? It is 2. So 2 times, remember when you're dividing like bases, what do you do with your exponents? You're going to subtract. So you're going to have negative 3 minus negative 5, which I know gives me 2. So times 10 to the 2nd power. This is in scientific notation, so that's all you can do. Okay, on checkpoint, I have a power of a product, so I have to distribute this power. So I'm going to have 2.01 squared times 10 to the negative 14. Power to a power, we multiply. Okay, what is 2.01 squared? I get 4.0401 times 10 to the negative 14. Is this in scientific notation? Yes, it is. So that's all we can do. Then on number 4, scientific notation, and we are dividing. So I'm going to have 4.8 divided by 6 times 10 to the negative 4 divided by 10 to the negative 4. 4.8 divided by 6 gives me 0.8 times, dividing like bases, I subtract exponents, so negative 4 minus negative 4 is going to give me times 10 to the 0 power. All right. Is this in scientific notation? No, it's not, because 0.8 is not 1 or bigger. So I'm going to drop down my times 10 to the 0 power. Forget that it's there. And I'm going to change 0.8 into scientific notation. So it's going to become 8 times 10 to the I moved it to here. It was here, so I had to go what? Back one? Okay, so that's going to leave me with 8 times 10 to the multiplying like bases. We add their exponents. Negative 1 plus 0 is negative 1. Now it's in scientific notation. Alright, that is lesson 8.4.
Amy DeLuna, if you're in the building, please come to the office.